Good day to all. Today we are going to see about that assembly line balance. What is the purpose of that assembly line balancing technique? There are 8 main points in that assembly line balancing. In that first one is to equalize the work load among the assemblers. Here the assembler means the person who is working in that particular workstations. He is called assembler. If there are 10 assembler means that workload must be even for all assemblers. Thus this point is to equalize the workload among the assemblers. Then to identify the bottleneck operation and to establish the speed of the assembly line. Then to determine the number of workstation for the particular production, how much number of workstations should be there, that should be determined by this assembly line balancing. Then to determine the labor cost of that assembly and packout, to establish the percentage workload of each operator, to assist in plant layout, to reduce the production cost. First one is R value. The R value goes behind each operation. The plant rate is the goal of that each workstation, and by putting an R value on each line operation, one keeps that goal clearly in that focus. Then the cycle time is nothing but the standard time. The time standard is the cycle time. Then how we can calculate the number of stations? The number of station is nothing but which is equal to cycle time divided by R. Then the average cycle time is equal to cycle time divided by number of stations. This is the formula for number of station and the average cycle time. Then the line efficiency. How we can calculate the line efficiency? Sum of hours per unit divided by sum of hours per unit balanced with the 100%. For example, if that sum of hours per unit is 0.055823 and sum of hours per unit line baseline 0.06960 means we can get that 84% of that line efficiency. Then the production rate. We can calculate the production rate with the formula of dA by 50 into SWHSH, where RP is the average hourly production rate with the unit of units divided by R. Then dA is equal to annual demand with the unit of units per year. Then SW is equal to number of shifts per week. HSH is equal to as per shift. This is the equation assumed for 50 weeks per year. See this data, the annual demand as well as number of shifts and hours for shifts for that particular workstation, it will given by the formula. We can get these data from that problem. Then the cycle time can be determined as Tc equal to 60E divided by Rp, where Tc is cycle time of the line with the unit of minutes per cycle, and Rp is equal to production rate units per hour, where E is equal to line efficiency. Then the cycle rate, it can be determined as Rc equal to 60 divided by Tc. We previously got that Tc value. From the Tc value, we can get that Rp. See, Tc equal to 60 divided by Rp. Then we'll substitute the Tc value here. Then we'll get that Rc value. Rc equal to 60 divided by Tc, where Tc is equal to cycle rate. With the units of cycles per hour, Tc is in minutes per cycle. Line efficiency E therefore defined as E is equal to Rp divided by Rc, which is equal to Tc divided by Tp. This is the formula for that line efficiency. Rp divided by Rc equal to Tc divided by Tp. Then the number of workers on the line can be determined as small w equal to WL divided by AT, where W equal to number of workers on the line. WL equal to workload to be accomplished in the given time period. AT is equal to available time in that particular period. See, WM is equal to workload to be accomplished in that given time period. It stands for workload, WL. As same as AT, it stands for available time in that particular work period. So WL is equal to RP into TWC. Here TWC is nothing but work content time with the units of minutes per piece. Using that previous equation, we also have WL is equal to 60E divided by TWC divided by TC, where TC already we get that before formula. With this formula we'll get the TC, and that TWC is nothing but here we can get that TWC, work content time. So from these data we'll get that WL. The available time in that period 80 is equal to 60E. 60E here is nothing but that available time. So substitute these forms for WL and 80 into W equation. We can get that W is equal to minimum integer greater than or equal to TWC divided by TC. If we assume one work per station, then this ratio also gives the theoretical minimum number of that workstation on that time. These are all the formulas that we can using for that assembly line balancing. In that assembly line balancing, surely you'll get one big questions. In that assembly lines, there are three type of algorithms are there. First one is line balancing algorithm, and second one is RPW method. Third one is weight bridge method. These three methods is used to find out that TC, TWC workstation, and all of that assembly line balancing problem. So we will see in these problems in coming videos. Thank you.